Understanding Materials, Lecture 1 by Lee Burton. Materials are central to modern society. In buildings, vehicles, and electronics. Materials are also central to a clean energy future. For example, in batteries, solar panels, or nuclear reactors. It's possible to improve components individually. But how do we know which materials are best? For example, copper against steel, or steel against copper. Solar panels aren't actually made of car parts, by the way. Even a small amount of material has billions of atoms. Which can make understanding materials seem impossible. Luckily, the atoms are usually not random. Elements have preferred neighbor sites, such as iron atoms prefer to have 6 neighbors. Or for silicon, atoms prefer 4 neighbors. This leads to repeating order or symmetry. The smallest repeat of atoms is called a unit cell. The unit cell and symmetry together can approximate infinity. Like how parallel mirrors show endless space. The real three-dimensional unit cell of silicon looks like this. Notice each atom has 4 neighbors. So with symmetry, billions of atoms can be treated as just a few. The next step is to better understand the atom itself. Rather than a simple sphere, atoms are composed of a point nucleus and an electron cloud. Electrons in atoms can only exist in a finite set of states. Each of these states has a corresponding energy. There are a lot more than just 3 possible states. For 2 atoms, the states can interact. Either constructively, leading to a lower energy state, or destructively, leading to a higher energy state. The same is true for 3 atoms, or 4, or 5, etc. But for materials, there are billions of atoms. So we use the unit cell to approximate infinity. Now the allowed states become continuous bands. What that means is, once the nuclei and electrons are decoupled, the electron states all interact like before. Creating an electron density that is wave-like, which, when viewed as a density profile, goes from highly in phase at low energy to highly out of phase at large energies. This is how we model the atomic and electronic parts of materials. This is an accurate simulation of electron density in silicon, by the way. In lecture 2 we will go further to look at the details in these bands and how some energies can never be occupied, which is how solar panels make clean energy. Understanding materials, end of lecture 1.